Good day, students. I hope everybody is doing great. Good. Today, our strands is algebra. Our substrands is patterns and relationships. Under the patterns and relationship, we are going to talk about triangular numbers and square numbers. You'll use all the methods that you can use to obtain these triangular numbers and square numbers, and then list them in order. Okay. Our lessons have been taken from the new curriculum of the BS6. Strand 2, Substrand 1, Content Standard 1, and then Indicator 1. Our main strands here is algebra, substrands is pattern and relationships. Under the patterns and relationship, what you're supposed to know is triangular numbers and square numbers. Good. When we talk about triangular numbers and square numbers, you first take the triangular numbers and deal with it. Later, we'll come back to the square numbers. The triangular numbers, we have some numbers that we call them triangular numbers. There are also numbers like the even numbers, odd numbers, counting numbers, whole numbers. Okay, but there are certain numbers that we call them triangular numbers. Why are they called triangular numbers? These numbers are obtained by adding the consecutive or continual counting numbers. The triangular numbers, before you can get a triangular numbers, unless you add the consecutive counting numbers or continuous counting numbers. And I hope you know the counting numbers start with 1. So when you begin to add all the counting numbers, the answer that you get is the triangular numbers. So triangular numbers are numbers obtained by adding the consecutive or continuous counting numbers. It can also be calculated by using or by the use of models, and then by the use of a formula. The formula is n times in the bracket n plus 1 all divided by 2. We can use models to find the triangular numbers, or we can use a formula which is n times the bracket n plus 1 all divided by 2. Or we can use the patterns of adding the consecutive counting numbers, and that one too, you can use it to find the triangular numbers. Okay, so these are the 3 methods that we can use to find the triangular numbers: using the patterns by adding the consecutive counting numbers, or using the models to draw triangles and other triangles to make sure that they follow a certain pyramid, or using a formula and then you do the substitution to do the calculation for the triangular numbers. So you will use all the 3 methods to find the triangular numbers that is in the midst of the counting numbers. Okay, good. Later we will come back and talk about the square numbers, which are also obtained by adding the consecutive or continual odd numbers. So the triangular numbers is adding the continual counting numbers, whereas square numbers are obtained by adding the consecutive or continuous odd numbers. Okay, good. There's a formula for finding the square number, which is n raised to the power 2, or sorry, n exponent 2, or n power 2. That is the square number. But we are going to talk about the triangular numbers. So let's quickly solve one more triangular numbers here. Okay. Example. Use the pattern to find the first, second, third, fourth, and fifth triangular number. Okay. So we are going to use the pattern to find the first triangular number, the second triangular number, the third triangular number, and the fourth triangular number. The last one is the fifth. We can be asked to find the 30th, 40s, and go, but let's try and follow this precedent so that we can use it to find other triangular numbers here. When you talk about the first triangular numbers, we know the definition is to add, or the triangular numbers are obtained by adding all the consecutive or continuous counting numbers. So when they ask you to find the first triangular number, it means you add all the counting numbers up to 1, or the first counting number. You add the first counting number. And we know the first counting number is only 1, so you are not adding it to anything. So that is, you add all the counting numbers up to 1. The second triangular number means what? Add all the counting numbers up to 2, or add the first 2 counting numbers. Add the first 2 counting numbers. That is in the series form. So you add the first 2 counting numbers. The third triangular number means what? It means you should add all the first 3 counting numbers. And I hope all the first 3 counting numbers you know. Good. And then the fifth or the fourth triangular number means what? We should add all the counting numbers up to 4, or the first 4 counting numbers. The first 4 counting numbers. When you add the first 4 counting numbers, the answer that you get is the fourth triangular numbers. To get the fifth triangular numbers, you add all the first 5 counting numbers. All the first 5 counting numbers, and then you get what? The fifth triangular number. When they ask you to find the 20th triangular number, it means you add the first 20 counting numbers together. The first 20 counting numbers, and then you get a 20th triangular number. When you are using the pattern formula to find the triangular numbers of the first, second. So let's quickly write our solution here. Good. Now, the method that we are using is the pattern method. Is the pattern. Good. So we are going to find the first triangular numbers, the second triangular numbers, the third, the fourth, the fifth. After then, you can solve all the triangular numbers that you wanted to find. Okay, good. So let's do the first 5 here. So here the question says we should find the first triangular numbers here. So the first triangular numbers. The first triangular numbers, which is the addition of the first counting number, okay? And the first counting number is only 1. So we have the 1. We have the 1 here. And then the answer is also 1, okay? Because when you add the first counting number is only 1, so 1 plus nothing will give you what? Will give you the 1 itself, okay? Good. Then we're done with the first triangle. So the first triangular number here is what? So let me add the 1 plus here. That is 1 plus, okay? 1 plus nothing because that is the first one, okay? Good. The second triangular number is the second triangular number is here. Good. Which means that we should add the first two counting numbers. The first two counting numbers is 1 plus 2, okay? And that will give us what? 3. So the second triangular number here is 3. Good. Then the fourth or the third triangular number here. The third triangular number here is you should add the first 3 counting numbers. So if you want to find the third triangular numbers when you're using the parting method, you add the first 3 counting numbers. The first 3 counting numbers are 1 plus 2 plus 3, okay? And then the answer here, 1 plus 1, 1 plus 2 here is 3 plus 3, that will give you 6, okay? So the third triangular number is 6. 6 here, okay? Good. Six. Good. Then the fourth triangular numbers means we should add the first 4 counting numbers because triangular numbers are obtained by adding all the consecutive counting numbers. So when they ask you to find the fourth, it means add all the first 4 counting numbers that you know, and then you get the fourth triangular number here. So the fourth one means what? We are adding the first 4 counting numbers. The first 4 is 1 plus 2 plus 3 plus 4. That is the first 4. And when you put them together, the answer here, 1 plus 2 is 3 plus 3, 6 plus 4. That will give you 10. Okay. Good. That will give you 10. And then the fifth triangular numbers here means what? We should find that is the fifth triangular numbers here means we should add all the first counting numbers and the answer will be the fifth triangular numbers here. So the first counting numbers are the 1 plus 2 plus 3 plus 4 plus 5. Okay, good. Plus 5. And then when you add them, you get what? 1 plus 2 is 3 plus 3, 6 plus 4, 10 plus 5, 15. And that is 15. That is the first 5 counting numbers when you add them. Okay, good. Now, the first triangular number means you are adding the first counting number and the first counting number to be only 1. Okay, that is why 1 plus nothing that gave us 1. So the first triangular number is 1. The second triangular numbers means we should add the counting numbers or the first 2 counting numbers, And then when you add the first 2 counting numbers, the first counting number is 1. So the first 2 counting number here. So the 3 here is what? The second triangular number. So then the third triangular number here is what? Is to add the first 3 counting numbers, and you have the 1, 2, 3, the first 3. When you add them, you get 6. So the 6 is the third triangular numbers here. The fourth triangular numbers here, when you're using the parting method, you add the first 4 counting numbers, and when you add them, you get what? 10. Okay, so 10 is the fourth triangular numbers here. In order to get the fifth triangular numbers, you must add all the first 5 counting numbers. The fifth, you add the first 5. The sixth, you add the first 6. The seventh, you add the first 7. Okay, to get the triangular number. So here, the fifth triangular number here, you add the first 5 counting numbers, and then when you add them, you get what? 15. So these are the triangular numbers up to 5. Okay, so we have 1, 3, 6, 10, 15, and then the rest. Okay, and I hope with the pattern precedent, you can use it to find the remaining triangle, the 7th, the 8th, the 10th, the 100th. Then you use the pattern, you add the first numbers or the first positional number that will be given to you to get a triangular number. Okay, let's also use the formula to check whether you still get the same answers here. Okay, so these are the triangular numbers that is also here too. So the next one here is what? The formula, how to use the formula to find the triangular numbers. So without waste more time, we use the formula to find the triangular numbers here. And this is how the formula looks like. Use the formula n times or any number attached to the bracket means that number is multiplying those numbers in the bracket. Okay, so it could be n attached to a bracket, n plus 1 all over 2, or n times in the bracket, n plus 1 bracket close all over 2. Okay, to find the first, second, third, fourth, and fifth triangular numbers here. So let's quickly solve this one. We write our solution here. Good. Now, the first triangular number is good. Because we are using the formula is n times what in the bracket n plus 1 all divided by 2. Okay, so because we are supposed to find the first triangular numbers, which means that the first will represent the number. Then what number are you finding, which is the first triangle? So the n will be 1. Okay, so then here n is equal to 1. Okay, so you substitute the 1 into the equation. Okay, good. So here we have 1 times in the bracket here 1 plus 1 all over 2. Okay, good. And then when you proceed, you add the 1 in the bracket first. So you have 1 times in the bracket we have 2 all over 2. Okay, which now is 1 times 2. Okay, all over 2. Because there's a multiplication sign between the 1 and 2, you can use the 2 to cancel the other numbers here. So 2 goes here, 1, 2 goes here, 1. Okay, great. Now we have 1 times 1 remaining at the top all over 1. Okay, and then we have 1 over 1, and the answer is what? 1. Okay, so the first triangular number is what? Is 1. Okay, good. Let's solve the second triangular number using the formula. Okay, good. So the second, that will be the second triangular number is here, and then you're supposed to use the formula. Okay, good. Now using the formula, you first quote the formula here, and that is n times the bracket here, n plus 1 all over 2. Okay, because we wanted to find what the second triangular number is here. So here n is equal to 1. Okay, or n is equal to 2 because we are finding the second. So the n will be 2. So you do the substitution. Here will be 2 times to bracket here 2 plus 1, then all divided by 2. So here you do the substitution. N is what? N is 2. So you do the substitution. You put 2 in place of the n. Okay, good. Now let's proceed. when you proceed, you have the 2 times, then you add the 1 in the bracket, which is 3, okay, all over 2. Because there's a multiplication sign between the 2 and the 3, you can use this 2, goes here 1, and 2 cancel this 1, 2, 1, okay? Now you multiply the remaining numbers at the top, which is what? The 1 times 3 all over 1. 1 times 3 is 3 over 1. And now the answer is 3. Okay. So the second triangular number is 3. When you use the formula to find the second triangular numbers, that one is 3 here. Good. Let's find the third. The third triangular numbers here means good. The third. So let me code the formula first. So finding the third triangular numbers means now the formula is n times the bracket here, n plus 1 bracket close, all divided by 2. Okay, good. Now because we're supposed to find the third triangular number, so n is equal to the 3. So you substitute the 3 into the formula and then you solve. Okay, good. Now we have 3 times into bracket here, 3 plus 1, then all over 2. Okay, good. Now we have 3 then times in the bracket on we have 4. When you add the 1 in the bracket, all over 2. Good. Because there's a multiplication sign between the 3 and the 4, then we can use the 2 to reduce the 4. Okay, great. So 2 goes here 1, 2 goes here 2. Okay, good. Then the remaining numbers here is 3 times 2 all over 1. 3 times 2 is 6 over 1. And the answer here is 6. Okay, so which means that the third triangular number is what? Is 6. Okay, good. Now let's find the fourth triangular numbers here. Okay, good. Fourth triangular numbers here. Good. Because we wanted to find the fourth triangular numbers here, then our n will be replaced by 4. Okay, at the formula. Our n will be replaced by the 4. Therefore, the formula is n times the bracket here, n plus 1 all over 2. Okay, Good. And then you substitute the 4 in place of the n. So then we have the 4 times, therefore 4 plus 1 bracket close, all divided by 2. Okay, good. Then you do your computation, the bracket first. Okay, 4 times, and then when you add the bracket, you get 5, all by 2. Because we have the multiplication sign between the 4 and 5, we can cancel any of the 4 and 5 against the 2. So you choose a number to do the cancellation. Okay. Good. Now 2 goes here 1, 2 goes here 2. Okay. Then you write the remaining numbers here, which is 2 left times what's 5. Okay. All over 1. Okay. This one we have cancelled. Now 2 times 5 is what? 10. Okay. Over 1. And the fourth triangular number is 10. Okay. Good. Now let's find the fifth. The fifth triangular number here. Okay. The fifth triangular numbers, which means that we're supposed to find the fifth here. When you're using the pattern, we add the first 5 counting numbers to get the fifth triangular number. But here, the formula, because we are finding the fifth triangular numbers, our n here will be equal to what? 5. So that you substitute the 5 in place of the n and then solve. N times, anytime you have a number attached to the bracket, it's the same as the one we stated. It means there's a multiplication sign between the number and the bracket, okay? So the formula can also be written in this form. N attached to the bracket, which means the n is multiplying those numbers in the bracket, okay? Then all over 2. Mostly, this is how the formula looks like. So any number that attached to this side, there's a multiplication. So it's not always that your formula will be in this form. Okay, good. So expect this one too. Then we substitute the 5 in place of the n. We have the 5, then attached to a bracket here, and then we have 5 plus 1 all over saying 2. Okay, good. Now with this, we said any number attached to the bracket means that number is multiplying those numbers in the bracket. Okay, therefore we have 5 times, then you solve the one in the bracket first, then you get 6. Okay, all divided by 2. Are you okay? Good. Because of multiplication sign between the 5 and 6, we can use the 2 to cancel any one of them here. Okay, so any one of them, so you can use this 6 and the 2 because they are the even numbers. So 2 goes here 1 and 2 goes here 3 here. Okay, good. Now you write the remaining numbers, which is 5 times what? 3 or 1. You can never use 1 to cancel numbers, so you proceed, which is 15 over 1. And the fifth triangular number is what? Is 15. Okay, good. That is how you find the fifth triangular numbers. Now, let's write all the triangular number that we have stated here. Okay, now we said the first triangular number, you got 1. The second, we get what? 3. The 4, the third was 6. And then the fourth, 10. And then the fifth, 15. And I hope you can also use this formula to find any, the 13th, the 10th, any of the triangular number that will be asked. Okay, good. Now, we said we have 3 methods to deal with that. Let's quickly use the last one to solve the triangular number here. Okay, use the models to find the first, second, third, fourth, and fifth triangular numbers. The models, we are going to use the shape to find the triangular numbers here. Okay, good. So let me write my solution here. The use of models to find the triangular number. Good. Now with this, we said the first triangular numbers. The question here is to find the first triangular numbers, means you should draw one triangle. Okay, when you're using the models, you draw only one triangles here. So let me start my diagram from this side. So the first triangular numbers, it means you draw only one triangles, and then here will be the first. Okay, the first triangular number, and then because it's only one triangle. Okay, good. Let me use different color to identify it well. That was first, okay, first triangular number, and then it's only one triangle. Okay, good. Let me extend this one to this one. It's only one triangles that we have. That is one triangle. Then to get the second triangular numbers, it means we should add, second means we should add a 2 additional triangle to the first one. Okay, so the second triangle, we are going to add 2 more additional triangles to this one. Okay, but the shape will still remain pyramid. Okay, now so when you add these 2 additional triangle, here is the second. Okay, the second triangular numbers, and when you add the first triangle to the second triangle that you have drawn here, you add it to the previous one, you get 3. Okay, so you get 3 triangles. Okay, good. You get 3. We have 1, 2, 3. Okay, then the third triangular numbers means what? We should add 3 more triangle to the previous triangles. Okay, so we are going to draw 3 more triangles to this one to get the third triangular numbers. Okay, so we are going to get the 3 more triangles. Okay, so when you add the 3 more triangles, these drawings are not drawn to scale. Okay, that is why the lines are not, but the main objective is to know how many triangles are you adding to the previous. Okay, here is the third triangular numbers, and when you add all the triangles that you have added to the previous, the first one is 1, the second one is 2 added to the 1, and the third one 3 added to the previous. So 1, 2, 3, 4, 5, 6. Now you have gotten 6 triangles. So the fourth one means we should also add 4 triangles to the previous ones that we have. Okay, we have add 4 more triangles to that. Okay, good. Then you design them. So these are the fourth. Okay, the fourth triangle numbers, and then using the model, because the fourth means we should add 4 more triangles to the previous triangle that we have in hand. Okay, and when you add the 4 to the previous, you get 10. Okay, now the total triangle up to the first 4 is what? The extent that you have here. Then the fifth triangular numbers here means we should add the first 5 triangles, or we should add additional 5 triangles to the previous one that we have. Okay, and now we're going to add additional 5 triangles here. So we have the 1, we have the 2, you follow a certain patterns here. So now you have, these are the additional 5 triangles that you are going to add to the previous one that we have. Okay, now which means that the fifth triangle number means when you are using model, you add additional 5 triangle to the previous, and when you add additional 5, you get what? 15. Okay, 15. So the C's, if you're using the model, the C's, you add additional 6 triangle to this. But Within the three method, the best one is using the formula, okay? That will help you to find the huge numbers, because you can use the patterns and the model to find the 50th triangular number. And that one, I don't know where you are going to draw all the triangles, or where you are going to add the consecutive counting numbers up to 50. No, that one is huge. Okay. So it's a huge task that you can't do. But when you're using the formula, just substitute the 50 in place of the n, and then you solve. Okay, so always try and use the formula, okay, to find the triangular numbers. But you can also do this to double check what you have done, okay, so that you can have a confidence in your answers when you have additional two methods that we can use to find the triangular numbers. Okay, good. Then let's quickly talk about the square numbers, okay? The square numbers. Yeah, once you have done with the triangular numbers, and we are also done with how to use all the three methods using the patterns, which means that we add the continuous or the consecutive counting numbers, and then to get the triangular numbers. And we also told that the formula is what? N in the bracket n plus 1, and then all divided by 2, okay? And multiplying the bracket here, and then inside the bracket we have the n plus 1 bracket close, all divided by 2. And we also realize that that method, or using the formula, is the best method that we can use to find the triangular numbers, rather than choosing the patterns, adding all these consecutive counting numbers, or using the models to draw the series of triangular numbers to add it to the previous triangle. So I think we have done with the triangular numbers. Let's quickly talk about square numbers. When you talk about the square numbers are also obtained by adding the consecutive or continuous odd numbers. Continuous odd numbers, okay? So the square number, the difference between the square number and triangular numbers here is that the square, we add the continuous or consecutive odd numbers before you can get a square number, okay? But the triangular numbers, we add consecutive counting numbers. So the difference is the counting numbers using as the base of the triangular numbers, while the odd numbers are also used in place of what? The square numbers, okay? So when you talk about the odd numbers are the numbers that are not divisible by 2. You cannot divide odd numbers into 2 equal parts, okay? Definitely, there will be a decimal. So using the odd numbers, I hope the odd numbers start with the 1, then in a consecutive way is 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, in that order, okay? Numbers here, 2 can never divide them equal parts, and they are odd numbers. So when you begin to add the continuous odd numbers, from the 1, you add it to the 3, you add it to the 5, you add it to the 7, you add it to 9, you add it to 11. When you begin to add the consecutive what? Odd numbers here, when you are adding them continuously, consecutive, in a serious way, okay? When you begin to add these numbers, the answers that you get is what? Is the square numbers. By simple put, they can also use a formula n raised to the power 2, or n squared, or n exponent 2, or n power 2, off. Okay, so these are the two methods that we can use to find the square numbers. Okay, so let's quickly solve one more examples under the square numbers. Okay, good. Now, example, use a pattern to find the first, second, third, fourth, and fifth square numbers. Okay, now we are going to use pattern to also obtain the square numbers here. And let me write the solution here. Good. Now the use of pattern. That is the pattern method. Okay, good. So the first square numbers here. When they ask you to find the first square number, it means you must add the first odd number. You must add the first odd number. And if you want to add the first odd number, which will be the one, the first odd number plus nothing here, okay? The answer here is what? 1, okay? For the first odd number, a 1 pet, okay? Aside 1, you don't have additional odd number be a 1 HB, okay? Good. Now, the second square number here, the second square number also means we should add the first two odd numbers. The first two odd numbers. The first two odd numbers is 1 plus 3, okay? 2 is not an odd number, but 3 is an odd number. So the first one is 1, the second 2, or the second odd number here, and that one is 3. So when you add the first two odd numbers, the answer is what? 4. So the second square number is 4, okay? Good. The second square number is 4. Good. Now let's see the third square number here. The third square number here, the third means we should add the first 3 odd numbers, because square numbers are obtained by adding the consecutive odd numbers or continuous odd numbers. And the first 3 odd numbers, when you add them, you get the third square number, okay? So the first 3 odd numbers are the 1 plus 3 plus 5. 4 is not an odd number, okay? So we said the odd numbers are numbers that can never, okay, that can never be divisible by 2. And then when you add them, 1 plus 3 will give you 4. 4 plus 5, that will be 9. Okay, so the third square number is what? Is 9. Okay, good. Let's see the fifth square number here. The fifth square number, or the fourth, rather, the fourth square number here means we should add all the first 4 odd numbers. If you want to get a fourth square number, then you're supposed to add all the first 4 odd numbers. Okay, so the first 4 odd numbers, we have 1 plus 3 plus 5 plus 7. Okay, good. These are the first 4 odd numbers. When you add them, the answer is what? 1 plus 3 is 4 plus 5, which is 9. 9 plus 7, that is 16. Okay, so the first 4 odd numbers, when you add them together, you get 16, and 16 is the fourth square number. Okay, so to get the fifth square number, you add the first 5 odd numbers together to get the fifth square numbers. So the fifth square number here, we said a square number is obtained by adding the consecutive odd numbers. Okay, so the fifth square numbers means we should add the first 5 odd numbers. The first 5 odd numbers. So now the first 5 odd numbers, we have 1 plus 3 plus 5 plus 7 plus 9. Okay, good. So let me check. 1, 2, 3, 4, 5. Good. So now let's add. Okay. So here, 1 plus 3, 4 plus 5, which is 9, plus 7, 16. 16 plus 9, which is 25. Okay. 16 plus 9 is what? Is 25. That is 25. So these are the square numbers that we have established here. We said the first square number here is 1, because per the parting methods, we're supposed to add the first odd number, and the first odd number is only 1. So that is the 1. Okay. The second square number here is what? Is 4, because the second square number is obtained by adding the first 2 odd numbers. The first 2 odd numbers. And when you add the first 2 odd numbers, you get 4. The third square number is also obtained by you add the first 3 odd numbers to get what? 9. Okay, good. Then the fourth square number is also obtained by adding the first 4 odd numbers. The first 4 odd numbers, and when you add the first 4 odd numbers, we get what? 16. The fifth square number here is what? You add the first 5 odd numbers, and when you add the first 5 odd numbers, you get what? 25. So if you want to use the pattern method to find the other square numbers, like the 10th square number means you add the first 10 odd numbers. You add the first 10 odd numbers, and then you get your square numbers. Are you okay? Good. So these are the square number. So start with the 1, 4, 9, 16, 25, and then continuous. Okay, you can also continue from then. You find the first 6 square number, the first 7, the first up to the first 20 is not bad. Okay, at least you must know up to the first 20 square numbers. So you can use this pattern method. Adding the consecutive odd numbers will also give you the square what numbers. Let's quickly use the formula to solve this one. Okay, good. Now use the formula n raised to the power 2. Let me write the small 2 here. Okay, n raised to the power 2. That is the n raised to the power 2. Good. N raised to the power 2 to find the first, second, third, fourth, and fifth square numbers. Okay, let me write the solution. Good. Then with the formula, going to find the first square number here. A equal sign, I remember, which is the formula is what? N exponent 2. Okay, where this one will be n times n, because n exponent 2 means n multiplied by itself twice. So, and that one will be the answer. So now our n is what? Is 1, because we want to find the first square number. So n is 1, and then we have 1 square, which is the same as 1 times 1, and that is what? 1. Okay, good. Then the second square number here the second square number here is also, the formula is n square, which is the same as n multiply itself twice. Okay, and that one, a number multiplied by itself. Okay, that one too, you can get a square number. And here n is what? The formula n is 2. So we are going to use the 2, and we write it here. So here our n is 2. So you substitute the 2 into the formula, and then we have 2 square, which is the same as 2 multiply itself. When a number multiply itself, you get what? A square number. So 2 times 2 give you what? 4. So 4 is the second square number. Let's find the third square number here. The third square number 2 is obtained by which is n squared. Okay. So here, because you want to find the third square number here, so n is equal to 3. Okay. Then you must put 3 in place of the n. N squared is the same as n multiply itself n. Okay. When a number multiplies itself, that is the square. So therefore, we have the 3 square. 3 square means the 3 will multiply itself 3 twice. Okay, 3 times 3. And when you multiply 3 times 3, the answer is what? 9. So the third square number is 9. Okay, good. Let's see the fourth square number here. The fourth square number. The fourth square number here. And that one too. That one too. The formula is n squared. And here, because we want to find the fourth square number, so our n is equal to 4. So you substitute the 4 into the equation. N squared means what? N multiply itself. Okay, n. And that is the square. So we want to put the 4 in place of the n. So here will be 4 square. 4 square means what? 4 multiply itself twice. So 4 times 4. Okay. And then when you multiply, you get what? 16. So the fourth square number is what? Is 16. Let's see the fifth square numbers here. The fifth square number, to get the fifth square number, 2. Because we want to find the fifth square number, the formula is what? N squared, or n exponent 2, or n raised to the power 2. They are all names. Okay. So the fifth square here means the n will be equal to what? 5. Then n square means n multiply itself n. Whenever a number multiply itself, you get a square. Okay. So you're going to put 5 in place of the n. Therefore, we have the 5 square. 5 square also means what? 5 multiply itself twice. So 5 times 5. Okay. Good. And then 5 times 5 is what? Is 25. Okay. Good. Like that. Therefore, irrespective of the method that you choose, you still get the same what? Answers. Are you okay? Good. So now the first square number you got what? 1. The second is 4. The third is 9. The fourth we got 16. And then the fifth we got 25. Okay, good. You can also continue from the sixth, 7th, whereby you put the 7 in place of the n. 7 times 7, 6 times 6. When a number multiply itself, that is the square. Okay, good. And I hope you have understood the two topics. Okay, the triangular numbers, how to find the triangular numbers, method used to find the triangular numbers. We said triangular numbers are obtained by adding the consecutive counting numbers. Make note of that. The triangular numbers, we add the consecutive or continuous counting numbers. Why square numbers are also obtained by adding the continuous or the consecutive odd numbers. Okay, good. We can also use n times the bracket n plus 1 all over 2 as a formula for triangular numbers. And we can also use n raised to the power 2 or n exponent 2 for square numbers. The method will help you to solve the huge numbers. Okay, when you're using the pattern, use the formula to what? To solve the biggest questions, and then use the patterns to verify your answers or any other method that you know. Okay, now see you. Bye.